everyone, this is Miss Cave with a lesson on reflections. Yesterday we were learning about a type of transformation, which was a translation, and we learned that a translation, this, is a slide across the coordinate grid, and it can be horizontal or it can be vertical. If you'd like more information about translations, you can find my video on my page, and it's right before this video, so it's on translations. But today we're going to look at a different type of transformation. Transformation meaning to change. If something transforms, it changes. If you think back to the Transformer movies, in the Transformer movies we have isn't it cars changing into robots back and forth, robots to cars? So they're transforming, they're changing. So this unit is on transformation. So we learned about translations, and today we're going to learn about reflections. In our warm-up today, we saw two different reflections, or two different transformations. So we saw over here on the left, that's our translation that we learned about. And then here on the right, you can see that the shape, the purple right triangle, when it changed to the blue triangle, it actually flipped. I saw on your board, some of you wrote that B was a reflection because it was a flip. So the correct answer to this, A was actually our translation, B is going to be a reflection, and that's what we're going to learn about today. So it's not the same, because you can see that the translation actually just slides across the grid, where the reflection actually flips across an axis, either the X or the Y. So today we're going to learn about reflections and how to reflect shapes across the X or the Y axis. So a reflection, just like with translations, the SL stands for slide. What do you think the FL stands for? Flip. So this is a flip. So a flip can be across the x-axis. Okay, so we can be flipping up or down across the x, or it can be across the y-axis. So we have one or the other. So we've got two different types of flips. We're either going to flip shapes or reflect shapes across the X, or we're going to reflect them across the Y. So let's go ahead and get started. We're going to start with the X-axis, and we're looking at shapes on the coordinate grid. So up here with example 1, the figure shows triangle ABC. Graph the image of the triangle after a reflection across the X. Well, here's the nice thing. What I want you guys to do is follow along with me, because it's already been done for you. These have already been done for you. So you're just following along and listening to the video. So you can see that the original, and just make your little notes, the original triangle is right here on top. I know it's the original because it doesn't have the prime symbol. And what I've done is, when I'm graphing it, I'm looking at how far this is across the x-axis, so I want you to circle x-axis. So when it's going across the x-axis, each of the points of the shape are actually going to go across the x. So what you do for this is just like you would do for translations. You're going to take one point at a time. So we're going to look at the original A, and I see that original A is how many spaces above the x-axis? How many spaces is that? 3. So if original A is 3 above, what do you think the image of A will be? 3 below. So you're going to show your little counting. So this is going to be 3 below, because you're flipping each of the points. This is your line of symmetry. We talked about line of symmetry with quadrilaterals. So if I were to fold the grid right here, all of these points should match up, because our line of symmetry is going to be on the x-axis. So that's how we would know to place the A here. Okay, same thing with the C. If you look here, the original C is 1, 2, 3 above. Okay, so if the original C is 3 above, my new C is going to be what? 3 below. So it's the same distance from the X. And then the last one, our point for B, I'm going to count how far B is from the x-axis. 1, 2, 3, 4, 5, 6. This is 6 above. So B prime is going to be what? 6 below. So we're going to start at the X and go down 1, 2, 3, 4, 5, 6. So it's going to be negative 6. It's 6 below. Makes sense? So this is a reflection across the X. You can see that the shape goes, when it flips, okay, so it goes like this and it flips across the X. It's going across the X. You see how it's going from here? It actually has to go across the X to get down here. And then compare that with the one, we'll go ahead and look at this example 3. You see how this one actually reflects across what? Yeah, it goes across the y-axis. So this is a reflection of the y. So this is the y-axis, and the shape is actually reflecting across it. It's actually going this direction across the y-axis. So what's often helpful with this is to take a highlighter or something like that, and you can highlight your axis to make sure that you're crossing the shape over the correct axis. So if this is y-axis, I'm going to highlight my y so that I know that the shape is going to reflect across the y. Whereas this one over here, I'm going to highlight the x because it's reflecting across the x-axis. See the difference? But you do it the same way. You're going to count the number of spaces for each point. So this y was 1, 2, 3 over here. Okay? So y prime is going to be what? Also 3 to the right. 1, 2, 3, 3 spaces to the right. Okay? And then you do the same thing with z. Z was 1 to the left, or excuse me, 2 places to the left, right? So z prime is going to be 1, 2 places to the right. So you're just looking at the distance it is from the y because you're reflecting over the y. And then you do the same thing with your x. Your x, if I count over, my original is 1, 2, 3, 4, 5. So x prime is going to be 5 to the right. 1, 2, 3, oh, excuse me, 4. Thank you. It is 5? 1, 2, 3, 4. Oh, well, the paper was wrong. So your x prime is actually going to be here, guys. So change that point for us. So this should be x prime. There was an error on this foldable. So I'm going to retrace my shape like so. Okay, it is 5. So what I want you to notice, though, is that the shapes here, they're flipped, but they're still what to the original? They're still congruent. So with reflections and translations, they still give you a congruent shape. It's only been flipped to the opposite direction. Does that make sense? Okay. The only difference is it doesn't look exactly the same because it's been flipped. But if we turned it or if we unflipped it, we could see that it matched up. All right, let's look at another example down here. Let's look at example 2. This also shows this quadrilateral. Here's our original. and we're going to graph it, which has already been done for you, the quadrilateral after a reflection across the x. So I want you to circle where it says x-axis, and then either circle or highlight the x-axis. So I want you guys really to see the difference between a reflection over the x and over the y. You can see that each of these points has been reflected the same distance. So J is 3 above, right? So J prime must be what? 3 below. And you're not having to do this. We're going to do some practice in just a minute. But since you're not actually doing it, I do want you to show me that you know the numbers. So do what I'm doing here. And then H is also 3 above the x. So H prime is going to be 3 below the x. Wow, I didn't make this. So that should be H prime. So this should be H prime. And then what should this be? This should be G prime. Okay, so go ahead and change that. We found the mistakes. Because, and that's a common mistake that could be made. I mean, a teacher, whatever teacher made this, she made that mistake, or he, because it's easy to make. But if you do it one point at a time, you see how quickly we recognized that that should be H and that should be G. Let's check our J and our F. Is that one right? Okay, that one's right. So one of the things that you guys may notice is that when you reflect across the x-axis, the x-coordinate stays the same and the y-coordinate becomes the opposite. So we're going to use the room over here just to look at that relationship, because that may be helpful if you don't want to use the graph paper to do your translations. You can actually look at what's happening with the coordinates themselves. So let's just look at a couple of the coordinates. Let's look at F, since we didn't look at F. F is going to be 1, 2, 3, 4, 1, 2, 3, 4, 5. So the original F, right, write this on your paper, is negative 1, 2, 3, 4, negative 4, and then it's 1, 2, 3, 4, 5. Our F prime is going to be also negative 4, right? 1, 2, 3, 4, but then it's 1, 2, 3, 4, 5. It's negative 5. You see that? So the x value stays the same, and the y value becomes the opposite. It's multiplied by negative 1. You see that? When it flips over the x, are you writing this down? What I just wrote down right here? Wow, you guys are faster than me. Okay, so let's look at another coordinate. So then if G is, what are the coordinates for G? Write them down. Write down the coordinates for G, the original G, and let's see what they are. So the original coordinates for G are 2, 1, 2, 3, 4, 5, 2, 5. So based on this, it tells us when reflecting across the x-axis, the x-coordinate stays the same. So what that's going to mean is that G prime is going to be the same for x, because I'm reflecting over the x. It's going to stay in the same place. But instead of a positive 5, what is that going to be? A negative 5. Okay, let's look at the same thing for, we've got J. So the coordinates of J, negative 1, negative 2, negative 3. And then my x or y value is 1, 2, 3. So if that's true, if we know that the x coordinate is going to stay the same, but the y is multiplied by negative 1, J prime is going to be negative 3. It stays the same. And then what? Negative 3 becomes the opposite. So that's just a little helpful tip when you're looking for your coordinates. The x, when you reflect over the x stays the same. And you can see that from the graph. Here's the x, and the placement of the point stays the same place on the x. The only thing that changes is where it is on the y. So let's go ahead and try the last point over here. What's our last point? H. We had G, now let's look at H. So the original coordinates of H were 1, 3. Is that right? And that's going to change to H prime. So the x is going to stay the what? Same. And then the 3 is going to become a -3. So when reflecting across the x, so the x-axis, the x coordinate stays the same. That's easy to remember. When you're reflecting across the x, x stays the same because you're just going across it. You're not leaving its position on the x, you're going across it. You can see that this shape is simply crossing the x-axis and flipping as it does so. All right, the last example has us examine the relationship between the coordinates on a flip over the y. So if you look at these coordinates here, I'm going to highlight my y, and hopefully these coordinates are correct. And let's see if we can come up with the relationship for this. So I'm going to start with M. What are the coordinates of M, original? -1, 1, -1. It's this one right here. Remember, this is our original, and this is our, we can tell that this is our copy because of the prime symbols. So M is going to be 1, -1. And when I change M, its reflection, if you look over here, it's crossing over the y. So M prime now becomes -1 on the x, but it stays -1 on the y. So when reflecting across the y-axis, what stays the same this time? Yeah, when you reflect over the y coordinate stays the same, okay? And then the x becomes its opposite. So if we look at n, our original n is going to be, write that coordinate there, please. And then I want you to write the changed coordinate. So write your original n, the coordinate, and then write your n prime. And then let's see if we can find that relationship. So go ahead and do that now, if you haven't already. So what's our original n coordinate? Okay, our n is going to be 4, and then what? 4 on the x, -1 on the y. And then our n prime, you'll notice, when I reflect it, it's 1, 2, 3, 4. I forgot to put my prime symbols here. It's going to be -4, but the x value stays the same. It's -1. Again, that's just a rule that you can use to check your coordinates, but you can always use your grid to do it. Be careful. The thing that students most mess up is whether it's over the x or the y. So this is actually going over. When it does its flip, it actually flips over the y. So you're going across the y-axis or across the y-axis. All right, now we're going to try it with the other two coordinates. So we have MN. Now we're going to go with Q, excuse me. Q is going to be, the original is what? What is it on the x? No? 2, and then what? It's 2, and then my y is -1, 2, 3, 4, 5, 6. So then What do I know is true? I don't even have to look at it, right? Does my x change or my y change? Oops, sorry. My x is going to change. My x is going to become the opposite, -2. And what happens to my y value? Stays the same. Same thing for p. P is 1, 2, 3, 4, 5, 6 on the x, and -1, -2, -3, -4 on the y. Okay. P prime crosses, see how it crosses over the y. P prime is going to be the opposite of 6. What's the opposite of 6? -6. And then what happens to my y coordinate? Stays the same, so it's -4. So now we've seen the difference between a reflection and a translation. We've learned how to reflect over the x or the y, and we've also seen that there's a relationship between what's happening to the coordinates. When you're reflecting over the y value stays the same and the x becomes the opposite. And when we reflect over the x over here, the x value stays the same and the y value becomes the opposite. And that's going to be helpful when you have a lot of problems, or maybe you're just given the coordinates and you need to come up with the new coordinates. That's it for our foldable lesson on reflections. Now we're going to do some practice using our notes.